So this is section 3.5a. Our objective for today is the student will be able to solve a system of nonlinear equations algebraically. Now we've solved systems of linear equations where we used elimination, substitution, things like that to solve them. Now we're going to solve a system of nonlinear equations, which means at least one of the equations is nonlinear. So it has an x squared or an x cubed or something like that. So the big thing is just to go through some examples, because it's just a little bit different than what we did before, but the process is the same. So if we look at this first example, x squared plus x minus y equals -1. And the other equation is x plus y equals 4. So you can do these by substitution or elimination. I'll show this one both ways and you can decide which way you like. I usually prefer elimination, but let's do by substitution first. So if I was going to do substitution, I would always, since I have an x squared, I would get rid of the y. So I'm going to solve for y here and subtract x and get -x plus 4 equals y. And so then I'm going to take that and substitute in for y. And so we get x squared plus x minus, and then parentheses, -x plus 4 equals -1. Then I would go ahead and solve this. So I'm going to distribute this negative sign, change it to addition, change both. And so I get x squared and I get x plus x would be 2x. And then I get -4 equals -1. It's a quadratic, so I'm going to set it equal to 0. So I'm going to add 1 and get -3. And then from here, it's a quadratic, so we can solve it by any of those things we've worked with before to solve quadratics. You can factor. If it's just an x squared, you can take the square root of both sides, get the square root by itself and take the square root of both sides, or you could always use the quadratic formula. Some people prefer the quadratic formula because it works for everything, but I always try and factor first. So if we try and factor, it's -3 and 2, so that would be 3 and -1. So it's x plus 3 and x minus 1. So my answers are -3 and +1, and I'm done. So that's one way to do it. Okay, if we go back and we do it by elimination, so elimination, remember we get opposites, where the y's are already opposites. So we get x squared plus x is 2x. And then we get equals -1 plus 4 is 3. We move the 3 over. And we end up exactly what we were at before. So we can, again, do the x method. -3, 2. And then we get 3 and -1. So x minus 3 and x plus 1. Excuse me, x plus 3. And so again, our answers for x are -3 or +1. So we got the same thing for x both ways, but now we have to also solve for y. So I would just go, you can do it in either one, but I'm going to go ahead and check it in this one. So I'm going to plug in -3 for x. So -3 plus y equals 4. And then we're going to add 3, so y equals 7. So one answer is when x is -3, y is 7. And then we're going to plug in 1 and do the same thing again. 1 plus y equals 4. And so then we get, subtract 1, y equals 3. And so our other answer is when x is 1, y is 3. Because if you think about this, this is going to be a parabola. And this is going to be a linear line. And so it's going to cross in 2 points that are ordered pairs. And so you'll get ordered pairs for your answer here for x and y. So that's one example. So let's go through another one. Y equals -x squared plus 4. And y equals negative 4x plus 8. So a lot of people like substitution here because we have what y equals. And so if we do that, we can just take and plug this in for y here, or vice versa. So I'm going to go negative 4x plus 8 equals negative x squared plus 4. So we're going to set this equal to 0. So I always want my x squared to be positive, so I'm going to move the x squared over here. So x squared minus 4x, and then I'm going to subtract 4. So I'm adding x squared and subtracting 4. And so we get 8 minus 4 is 4. Again, you can always use the quadratic formula, but I like to factor when I can. So 4 and negative 4, so negative 2 and negative 2. So in this case, x can only be, because this would be x minus 2 and x minus 2, so x can only equal 2. We only have one answer. So then we can plug that in, plug it in here. So negative 4 times 2 is negative 8. Plus 8 is 0, so my ordered pair is 2, 0, and we have one answer. So this would be when we have this quadratic opens down, but it's going to cross at one point. Okay, whether it's there, whatever the case is. But we have our answer is 2, 0. Now again, you could have done this by elimination. If I go back, I could have just multiplied this by a negative 1 and then added these together. The y's would cancel. So we get 0 equals negative x squared and then plus 4x and then 4 plus a negative 8 would be negative 4. Again, I always want this to be positive, so I would pull a negative 1 out and get x squared minus 4x plus 4. But again, as you see, we can do the x method. 4 and negative 4, negative 2 and negative 2. And again, we get 2 as our only answer, and you plug it in. So works the same way. Either way, it's just kind of your choice on which one you are more comfortable using. Let's do one more, then I'll have you try a couple. So let's take x squared minus 5x minus y equals negative 2, and x squared plus 2x plus y equals 0. So I'm going to do this one by elimination. Our y's are already opposite, so we get 2x squared minus 5x plus 2x is a minus 3x equals negative 2. I'm going to set it equal to 0. So again, you can always use the quadratic formula, but I'm going to go ahead and try and factor again. So we get 4 and negative 3. Now, since it's positive, the only factors of 4 are 1 and 4 and 2 and 2. And none of those will add up to 3 because they both have to be positive or both have to be negative. So in this case, it's not factorable. We have to use the quadratic formula. So our A is 2, our B is negative 3, and our C is 2. So I'm going to go ahead and plug that in. So that would be 3 plus or minus the square root of 3b squared, which would be 9, minus 4 times 2 times 2, divided by 2 times 2, which would be 4. So we get 9 minus 4 times 2 is 8 times 2 is 16. So we get 3 plus or minus the square root of negative 7 over 4. And so we get 3 plus or minus I square root of 7. So you can see we got an imaginary number, so there would be no real solutions. And we just put no real solutions for that. So let's have you try a couple and see how you do. So the first one, x squared plus 3x plus y equals 0, and 2x plus y equals 5. So go ahead and try this one, pause the video, come back, and then see how you did. So, again, up to you how you do this, but I would do it by elimination. You could have solved for y and did it by substitution, but I'm just going to change, multiply that by -1, and then add the two equations together, so we get x squared. 3x plus a -2x is a positive x. The y's cancel, equal -5. Set it equal to 0. If you tried to factor that, you would get 5 and 1, and there are no factors that multiply together to give you 5. So we have to use the quadratic formula. So a is 1, b is 1, and c is 5. And so we get -b, so -1, plus or minus the square root of b squared, so 1 minus 4 times 1 times 5, all over 2 times 1, which is 2. And really, you should be able to stop right here because, again, when you look at the discriminant, this is going to be 20, and 1 minus 20 is going to be a negative number, so we know there's no real solution. But I'll go ahead and show you what you would have done. So we get 1 minus 20, so that would be -19 divided by 2. So we have an imaginary solution, so that means there's no intersection, no real intersection point, so there'd be no solution on this one. Okay, and let's do one more. Let's do 2x squared plus 4x minus y equals -2, and x squared plus y equals 2. So go ahead and pause the video. So if you did this one, I would do this by elimination because the y's are already opposite, so we can just add these together. 2x squared plus x squared is 3x squared, plus 4x equals, the y's cancel and the 2's cancel, so we get 0. So here's one where factoring again works. Pull out the greatest common factor, x, and then we get 3x plus 4. So again, you can set those to equal to 0 with a shortcut. What makes x equal to 0 is 0. Opposite this, -4 divided by 3 is -4/3. So those are our x values. So let's plug it in. If we plug in 0, 0 squared is 0. So we get y equals 2, so 0 and 2. And if we plug in -4/3, so -4/3 squared would be 16/9. Remember, you have to square the top and the bottom. Plus y equals 2. But I'm going to change that 2 into ninths. So that would be 18/9. Subtract 16/9, and that would be y equals 2/9. And so we get -4/3 and 2/9. And so those would be our solutions. So, what about if we have an x squared and a y squared? So that would be the last thing we're going to look at. So as an example, let's look at this one. X squared plus y squared equals 10. And y equals -3x plus 10. So we can't do elimination here because we don't have x squareds in both or y squareds in both. And to get rid of the variables, so we're going to have to do substitution. So we're going to take this and substitute it in for y. But that y is squared, so I have to go x squared plus -3x plus 10 squared equals 10. So now we have to FOIL this, because remember that squared means times itself. And if you FOIL this, you get 9x squared. Then you get a -30x and another -30x, so a -60x. And then 10 times 10 is 100. So we get x squared plus 9x squared minus 60x plus 100 equals 10. I'm going to simplify this and set it equal to 0. So x squared plus 9x squared is 10x squared minus 60x. And then I'm going to subtract this 10, so plus 90 equals 0. Now again, you could use the quadratic formula here. But I always try and factor first. And when you factor first, remember, after you set it equal to 0, you should always check for a greatest common factor. So I can pull a 10 out and get x squared minus 6x plus 9. Even if you're going to use the quadratic formula, you can pull out the greatest common factor and still work with smaller numbers. So I can still use the quadratic formula and do this with just the x squared minus 6x plus 9 and still get the same answer. So now we go up here and we get, if I factor that, it factors into x minus 3 times x minus 3, because 9 and negative 6 is negative 3 and negative 3, or if you recognize it's a perfect square, it's x minus 3 squared. But in either case, we get that x is 3. So now, since we know x is 3, we can plug that in. Go back up here and plug in. When x is 3, we get negative 9 plus 10 is 1, so we get 3, 1. All right? If you plugged it in up here, you would get 9 plus y squared equals 10. And then you get y squared equals 1, so y equals plus or minus 1. The problem is the minus 1 won't work here, so that's an extraneous solution. So we're still back to this 3 equals 1 because it has to work in both. So you can see these are a little bit more complicated. But again, same process, just takes a little bit more time. So let's have you try a couple now. So let's try this one. X squared plus y squared equals 16. And y equals negative x plus 4. So go ahead and pause the video, try this, see how you did. So if you did this, again, I would just substitute this in. So x squared plus, so I go parentheses, and I replace the y. So I have to remember, I have to square this now. So negative x plus 4 times negative x plus 4, which is x squared minus 8x, because we get a minus 4x and minus 4x plus 16. So I'm going to plug that in. I'm going to simplify this and set it equal to 0. So x squared plus x squared is 2x squared minus 8x. Now when I subtract that 16, that cancels. So now I can pull out the greatest common factor, 2x. Get x minus 4. So my answers are 0. 2x equals 0. And opposite this would be 4. So 0 and 4. So now I plug those in. I plug it in right here. So when I plug in 0, I get y equals 0 plus 4. So that would be 0, 4. And when I plug in 4, I get 4. That would become negative 4 plus 0, or plus 4, which would be 0. And I get 4, 0. So those would be my two answers, 0 and 4. Again, you can plug those in up here, but when you do, you get the, again, like if I plug 0 in here, I get y squared equals 16, and then I get that plus or minus 4, but the negative 4 doesn't work with this problem. So you just have to, I would always check it in the linear equation because it has to work for both. All right? So let's have you try one more problem, and then you can get started on the assignment. So let's do a fraction. X squared plus y squared equals 1, and y equals 1/2 x plus 1/2. So go ahead and try this, see how you do on it, and you can come back and check and see how you did. So again, I'm going to plug this in for y. 1/2 x plus 1/2 squared equals 1. So we have to go 1/2 x plus 1/2 times 1/2 x plus 1/2. So again, you can use decimals if you wanted. I prefer fractions. 1/2 times 1/2 is 1/4 x squared. And then we get a positive 1/4 x and a positive 1/4 x, and 1/4 plus 1/4 is 2/4, or 1/2. And then 1/2 times 1/2 is 1/4. So I get x squared plus 1/4 x squared plus 1/2 x plus 1/4 equals 1. Now here's where I prefer not to work with fractions. So I'm going to get rid of the fractions by simply taking my common denominator, which is 4, and multiplying everything by 4. So I get 4x squared. 4 times 1/4, the 4's cancel, so I get plus x squared. 2 goes into 4 twice, so 2x. 4's cancel, so I get plus 1 equals, I have to multiply everything by 4. So now we combine like terms, 5x squared plus 2x, move the 4 over. So I get minus 3 equals 0. Now, if we do that, it would be 5 times negative 3 is negative 15, and 2. So that would be negative 5. Actually, it would be positive 5. Positive 5 and negative 3. So that gives me my positive 2x. And then we would get, because this is not a 1, we have to build the box. And so we get 5x squared and negative 3, and then 5x and negative 3x. So this would be 5x, 3, first box is negative, x, and 1, so plus 1. So we get 5x minus 3 and x plus 1. So our answers, again, the shortcut is the opposite of negative 3 is 3 divided by 5, so 3/5. Opposite 1 is negative 1 divided by 1 is negative 1. So those would be our x values. Again, if you can't remember the shortcuts, just set those equal to 0 and solve. So now we have to go and plug those in. So I'm going to plug in 3/5 for x. So y equals 1/2 times 3/5. Plus 1/2. So that would be y equals 3/10. Plus, I'm going to change that to 10, so that would be 5/10. So y equals 8/10 or 4/5. And so one answer is 3/5 and 4/5. And the other answer, I'm going to plug in negative 1. So if we plug in negative 1, I'm going to go here. Y equals 1/2 times negative 1 would be negative 1/2. Plus 1/2 would be 0. And so this answer would be negative 1, 0. So fractions can make it a little tricky. Follow the steps. Your assignment today is not on the big ideas, because I want you to do this on paper and show the work. And the reason you're going to see on the next section is we can do these by graphing it, and it's really easy. But we need to understand the process of doing this mathematically. So you'll be doing these on paper, not the computer, and turn it in. So the assignment is on page 136, 15 to 23, the odds, and on page 127, 23 to 33, the odds. So you don't have a lot of problems to do, but they do take a little bit of time. So good luck on that.